Following on from the previous video, we got to this stage here, but now we need to establish where we need to integrate it from where to where. So we are releasing a particle at t0. It will fall down to here. So what this means is that on this diagram, what it means is this: the parametric equations here describes this path. You start from here, and then it will travel like this. So the parametric equations here describes this path. So if you want to release the particle here, then t0 here is really a constant. It doesn't change. If you want to release the particle here, then make t0 slightly smaller, because if you look at the parametric equations here, the parametric equations describes the path. It starts here and it will travel along here. So if you want to release the particle, let's say here, then make t0 slightly smaller. If you want to release a particle here, then make t0 slightly bigger than this one here. So t0 is a constant, it doesn't change. So looking at this here, we need to integrate it from t0 to this point here. Well, this point here, or that point there is really the same as this point here. So if you want to figure out where we need to integrate it to, then you've got to ask yourself, when will the particle be at its highest point? So looking at this, you've got to ask yourself, when will the particle be at its highest point? So you've got to look at this and then ask yourself, when will this be at its highest point? You see, this will be at its highest point when you make this to be -1. When would that be -1? It will be -1 at pi. So by the time t gets to pi, then it will be at its highest point. So looking at this here, we need to integrate it from t0. So t0 is just a constant to pi, because pi will be when it is at its on this diagram it would be at its lowest, but then on this diagram it will be at its highest. So we need to integrate it from t0 to pi. Okay, so we are now at this stage. We are now at this stage here where we need to integrate this. So the total time is given by us evaluating this thing here. Okay. So now to evaluate this, remember we've seen this and this before. You got to memorize these two here. We've seen these two before. Now look at this bit here. If you remember, if you look at this bit here, the angle here is always twice the angle here. It's always double the angle here. So if you make this, the angle here is always twice the angle here. So if you have this sine squared half of the angle here, then this thing here will be cos theta over 2. Because if you look at this now, this angle here is still twice this angle here. So we are trying to replace this here. So now times both sides by 2. So that will then give us this: 2 sine squared theta over 2 equals 1 minus cos theta. So look at this bit here. That's exactly the same as this. So we can now put this into here. Okay. So the reason why we're doing this is later on. Well, the reason why we're doing this is because there's a square root here. We want to get everything in terms of a square, so that later we can easily square root it. Well, anyway, we can put this into here. Okay, so that will then take us to here. That will then take us to here. Now use the same technique on this one here. Use the same technique. So looking at this here, but this time we're going to make use of this. So we are trying to replace this here, and then notice that this angle here is always twice this angle here. So if we were to do this, if we were to do this, cos squared half of this, so theta over 2, that will be 1 plus cos theta over 2. And then if you now look at this here, the angle here is still double the angle here, so it's still consistent. Now remember, we want this, so we only want this bit here. So now times both sides by 2, so that will then give us 2 cos squared theta over 2 equals 1 plus cos theta. So now take away 1, so we can then put that into this bit here. So that will then become this. That will then become this. Okay, and then use the same technique on this bit here. Use the same technique as this. Use it on this, and that will then give us this. That will then give us this. Remember, t0 is just a constant. It's just a number that doesn't change. It's a constant. So we are now at this stage here. I will continue in the next video.